for both for group data and for grouped data. Okay. So, well, we'll look at this formula. Set summation of x minus bar x squared all over n. That's from group data. X standing for the data points, y by x is the average of the data points. Actually, the absolute difference is what we are interested in, and that is why the square comes up, so that it will counter the effect of any negative value. Then n is standing for the number of observations. So, and then the standard deviation being the square root of mean will look like this. For example, in a group data, when the midpoint is found, the midpoint is now standing for x, and the bar x will be applied as appropriate. So, to have a demonstration, so let's look at the table here. This table has a total frequency or the number of observations to be 35. This is an ungroup data. And let's try and work out so that we'll fill this table and calculate our variance as well as the standard deviation. Are we ready?
Yes.
Are we ready? Yeah. Okay. I think you can see my slide enough. So if you can see that enough, so let's start to fill in this table so that we find our standard deviation as well as the variance as well as standard deviation. This is an ungroup data. Can we go? So what will be the value here?
3.4.
Good. So what will be the next one? 11.0.
11.
Okay. That's 1.7. I hope I'm right.
Yes.
17.
$14.
Okay. 14.4.
9.4. 23.2.
0. So, can we do the sum?
One to 6.5.
So, and the mean will be 126.5 divided by 35.
3.61.
3.61. Okay. So on this table, any other value in case there's a mistake? Is anyone having a question on that? So yeah. 3.61. Any problem with that? So now, are you seeing my screen?
Yes.
Okay. So you can see I changed into a cell.
Yeah.
So that they will. So yeah, let's try and find the values. This is this. Anyone? Any message here? Okay, none. So,
Doctor, which one you take?
yes.
You take the frequency or you take the X?
Oh, God. Thank you. Yeah, I think I took the frequency. Let me see. D32. Oh, okay. That should be C32. What happened? C32, E32, C32. Okay. This is D42. And the string. D42 and the string $. Okay. Is it correct now? Okay, 3.61, yes. 4.7, yes. 5.8, yes. Is it correct now?
Doctor, why got negative?
This one is 1.7 minus 3.61, negative.
Have to square right.
Is it right now?
No, doctor, the
Doctor,
final,
you forget to square.
if square it will no longer have any negative.
No. Oh, yeah, we've got to square. Let me put another cell. I wanted to do it first. Yes, insert, yes. Okay. This is see this. See, and this is good. So this is equal to this raised to the power 2. Okay. So right now, is it okay now? This one is without square. So this column, sorry, is the difference between the x and the mean, the by x. I'm representing this mu to be by x, and this is the column. So this one square give us this column. Is that okay now?
Yes.
Now the next thing is to multiply this column by the frequencies. F. And this will be this. This. So I hope it's correct. And the same thing down. Is anybody cross-checking? I hope it's okay.
Doctor,
So
how many decimal points we need to put? 2 only, right?
How many
Decimal places.
decimal places? I just want to wait for the final answer to put it at 2 decimal places.
Okay.
Yeah. This time, 2 decimal places is the convention. So I just want to finish to get the final answer so that the error will not be too much. Error of approximation. So the variance is, when we look at our formula here, this is the variance. The variance is the addition of all this divided by the number of observations. So our variance will be the sum total here. So we do. Let's see. So the sum total here is divided by total frequency. So, and this is 1.5. Is anybody cross-checking? So let's do quick.
Doctor, can you go back to the slide? Go back to the formula given in the slide.
Yeah. Summation of all this for variance, this is the summation of all this multiplied by this.
So I'm just wondering for the group data, why the below one is n minus 1? I thought it's n only.
Yes, different authors has aggregated that because of the assumed mean that mostly happen in group data, the frequency, the total number of frequency may be -1. So different authors. Some authors use n, other authors use n-1 to take care of error of approximation in getting the midpoints. Yeah.
So which one should we follow?
No, there's no one that is not correct. I've tried the two, and the margin is 0.0 something difference. So even if you look into different tests, there are explanations for that. But mostly in group data, n-1 is always adopted.
So during our exam, we just ignore the -1. We just proceed with the normal formula first. Is it okay?
Yes, the normal formula first is for here is because of the error approximation. You know, in group data, you assume mean, which is an assumption. So it's in an attempt to correct whatever error that can come from assumption is what the authors who prefer this does. You will see the two formulas when you even go into Google. Okay. Yeah?
Yeah, thank you, doctor. You already answered my question.
Yeah?
Okay, fine. Thank you so much, doctor.
So let's look at these results. Is it correct?
Yes, correct.
Okay. So now from here, when we say this standard deviation is the square root of this, standard deviation is the square root of variance, we can equally find the square root of the variance here to get our SD. $24. Am I saying this? Okay. Raised to power. Okay, I do square roots. Why? Why is it giving invalid?
It's not invalid, sir. The number is too long.
I know. I want to.
You have to
So I
adjust
can
the decimal
increase it.
places.
I was trying to increase the font and it's okay. Okay, now. This is the variance is 1.55. The SD is 1.25. So Later, I will tell us the interpretation of the standard deviation, because most of the time we use mean and standard deviation. And in advanced econometrics, especially when we are doing investment analysis, we use SD at times to represent the margin of the error of estimation. So that we'll be able to know if the error margin is wide or close. So by the time we work the next one, after that I will interpret what standard deviation, how it is interpreted in econometrics and in statistics. Okay? So now this is the same process. We can go through the same process to work out this one. The only difference is that we are going to calculate midpoint for this group data here, and as well have.
Doctor.
Yes.
Can you release this slide on the spectrum?
It's already there.
It's already there.
Oh, no. I'll put it on the spectrum, but so I guess I will put it, if it's not there, I'll put it on the spectrum. It's supposed to have been there. I think that's an omission. Okay. So look for this, there's the same process. We look at the midpoint, we get the midpoint, we get fx, but I've added something here, the absolute mean deviation, because there's something we call absolute mean deviation. And when we are working absolute mean deviation, it's about mean itself, not the standard deviation of the data sets. So look, using the same thing, work this one out. So, and it can be cross-checked by your analysis, so that I don't want us to waste time. Now that's how I'm bringing the one I've worked already. So when I work this is the midpoint, 33, 38, 43, 48, and so on up to 78. So the mean give me 51.4, and the total frequency is 50. So looking at fx, I got this. So looking at this x minus by x, these are the values. The column I put red is because I want to work absolute mean before doing very deviation. Absolute mean, you take absolute figures, irrespective of the sign beside them, the differences, and add together. That divided by the total frequency is what we call absolute mean. I just want to make that clear, that you may be asked for absolute mean deviation. So absolute mean deviation is just the deviation of the mean from the data set absolutely, without reference to their sign, either negative or positive. So, and if you do that, we get an absolute mean deviation. This is just for our consumption, for our information. Now, for the variance, we got this square multiplied by f, multiplied by frequency, we get this. So I'm interested in the total of this, which is 5822, divided by n, use n1, n first, to answer that question you just asked. Then the other time I use n minus 1 here. You can see there are two slides. First I use n, which give me this. Standard deviation give me 10.79. And when I use n minus 1, give me 10.9. So you can see there is just 0.02 difference. Just as I said, there's no more difference now, because I try different authors and what they mean by their the formula. So I get 10.9. I want to believe this is clear enough. Or is there any question?
No question, just a very new thing is the absolute. Absolute
Yes,
mean.
yes, absolutely. That's why I color it red too, because it's just you can read on and you find something absolute mean. It's in statistics. So this one is only talking about the difference, what's the difference between the mean value that we have gotten and our points, midpoints, the absolutely. So how scattered? Either they scattered to the left or to the right. So now I want us to do, because we need to dwell more on the interpretation of the standard deviation, because that is more applicable when we want to be applying statistics. So if there's no problem with this, we go to interpretation of SD. Are we ready? Or any other question?
Doctor, I just want to confirm. So the column in red is the absolute mean, but
Yes.
the last three rows, the last third is the absolute mean deviation.
Yes, this is for absolute mean deviation. That's why I said, you know, we didn't square this. This one doesn't need not to be squared. But the assumption is that we are taking absolute values, irrespective of their negative signs or positive signs. It's absolute. And when it's absolute, you consider everything positive. Any other question? Okay, these figures are correct, yeah. I did something. Yeah. Any other question? Sorry for not giving you this slide ahead. We say there's no other question, so that I will go to interpretation. So if there's no question, let's try and see why are we looking for the standard deviation? Standard deviations indicates how the data set is expected to spread out the data set. So the standard deviations is when you look at mean plus or minus, because the data will scatter either to the left of the mean or to the right, because mean is a central tendency. It's like a middle value. So what standard deviation shows us is that the percentage of the data set that must be within each standard deviation. One, if you had the standard deviation to the mean, for example, our mean value is 51.4, our 10.79 or 10.9. If you add it to the mean, you will get a value to the right. If you subtract it from the mean, you will get a value to the left. So the assumption is that 68% of all the data set in your observation will fall within mean plus 1 SD. So with this chart I'm trying to use to illustrate, it means if the mean is in the middle, if you plus or minus SD, 1 SD, the values between that bracket will be about 68%, not less than 68% of all the data sets. So their values will fall within that range. This will show us whether the data set is concentrated around the mean, or they are further away from the mean. rule number 2 is that 95% of the data will fall within mean plus twice its SD, plus or minus twice its standard deviation. So again, to the left or to the right, you will get 95% of all the data set. So it is expected that all this data set will be within the mean plus its 3 times its standard deviation. So this is about 99.7% statistically. Let's use our answers here to illustrate this explanation. Here, if I for our example, we have mean 51.4. And if you add 10.79 to 51.4, you get 62.91. If you take away 10.79 from 51.4, you get 40.61. So what this one is saying is that between the score of 40.6 to the score of 62.19, 68% of our observed values fall around this number. So my question now, how do we confirm whether this is right or not? You know, we say 68% of our data revolve around between 40 and 62. What it means is that those who score 40 and 62, up to 62, they are about 68% of our entire sample. So, is that clear? So that we go and cross-check whether it is true or not. Hello, class.
Yes, doctor, you can proceed first. Later
Okay,
we see
that
our
explanation
question.
is clear. Okay, if the explanation is clear, we'll go back to our data. We will look at those people who score between 40.61 to 62. How many of them out of our data? Is that clear?
Yes.
If it is clear, now let's get back to the data. So this is our data. Okay, 40, at least 40 point something, which is more than 40. We can start from 41. We can agree that the score is from 41. Is that clear too?
Yeah.
Then 62, we fall within those who score 61 to 65. So let's add those people who score this, who are within this score range. That will be 7 plus 11, 18, 18 plus 8, 26, 26 plus 6, 32, and 32 plus 4. That's 36. Am I correct?
Yes.
Yes.
Okay, now, what is the 36 when we want to find the percentage of these 36 people among the 50? So that will be 36 over 50 times 100. We want to know the percentage of those people who are within that score range. Out of our total population, or population of 50, so if 36 over 50 will be what percent? 36 divided by 50 times 100.
72.
72. Good. That means 72% are within the score of 41 to 65. So, you know, there's every tendency that among these people, some people score more than 62.19. So now, going back to our standard deviation table, we have 71%. That means that means this assumption is right, that not less than 68% of our population has a score between mean plus plus 1 times it is standard deviation. That is one thing, one fulfillment. We have fulfilled this argument. When we do the same thing for the second 2C2 standard deviation, we will find out that in that we have, that means we say 51.4 plus or minus 2 times the SD. So if you do 2 times the XD, that means the score range of those people that will fall within this range will be those who score 29 to those who score 72.98. So we can equally go back again to our table to confirm whether this one is more or less, whether we are fulfilling the assumption. And if you do the same thing, there's no score of 29, but at least we are from 31. So those who score from 31 to 72, about 49 students. So, and that means at least up to 95% are actually within that range. So within this score range of 29.82 to 72.98, we have about 49 of our population. And 49 divided by 50 multiplied by 100, that's about 98 something. That means we have, at least we fulfill, our data fulfill this condition that the XD, twice XD, about more than 95% fall within. And at least with this, we now know that the 3D, we capture the 100% of our population. If somebody did a mean, found a mean and standard deviation of a data set, and this assumption is not holding, something is wrong with the standard deviation, or something is wrong with the entire calculation. Do we understand that now?
Doctor, I have one question.
Yes.
How do we get the 68%, 95, and 99.7% in the beginning?
This is statistical decision rule. So when you study standard deviation very well, these decision rules are stated that when you get your standard deviation, it means that your mean score plus 1 times standard deviation will give you 68% of your data within that bracket. It's just like saying 37 degrees centigrade is the normal temperature for a human being. You know, I am not the one that calculated it. You are not, neither were you.
So meaning that it is fixed already, right? We no need to calculate for this.
Yes, it is a decision rule in standard deviation and statistics.
All right, thank you, doctor.
Yeah. So this is what some people use to know whether the report being given is actually correct or not. So, you know, somebody can give you a mean and standard deviation of a small standard deviation. By the time this one is put together, it will help us to check your data, whether you are reporting actually what your data set is, especially in research and in econometrics. Here, the next thing I want to explain is that, you know, I told you standard deviation in econometrics is taken as error. When we did BIE1002 the last time, remember when we are measuring the risk in investment, we use standard deviation to stand in for risk. So this one is telling us the risk of your mean not being realistic. So if this assumption did not hold after you are getting your standard deviation, something is wrong, either with the mean or with your standard deviation calculation. So if you hold, then we can now take your standard deviation as an error potential. So let's do another illustration of this standard deviation. Another illustration. Here, consider the level of satisfaction of mode of compensation for public land acquisition. Interpret the mean and the standard deviation. You know, this is a question. So, and I want to explain this scenario. The scenario is like, for a public land acquisition take place, properties were acquired. And you know, when in compensation, you can compensate by giving alternative property. We call it resettlement, or by money compensation. So by paying money for what has been acquired. So we assume that such thing take place. Some people agree to get resettlement instead of money. Some people agree for money compensation. So their level of satisfaction were measured, and they have average of 4 and 4.3 respectively. But the standard deviation for A, category A, group A, is 0.6, while the standard deviation for category B is 1.2. So do you understand that table now? Before we translate to the standard deviation measurements. So number one, if we give you who has more satisfaction, you know, 4.3 is greater than 4 as average mean of satisfaction. So we will always see from this table that those who get monetary compensation, according to their mean value, are more satisfied than those who are resettled with alternative property or with alternative land, in case whatever is acquired. So when we trust their standard deviation into action, for group A, you can see for group A, we have for standard deviation of 0.6. It means majority of them, 68% of them, have a satisfaction level of 3.4 to 4.6. Majority of them, with one standard deviation, you'll discover that majority, 68%, their level of satisfaction is above 3. But if you look at the group B, you can see their own level of satisfaction is between 3.1 and 5.5. So which one is more consistent? It is shown that a group A is more consistent because their level of satisfaction is closer to each other. 3.4 to 4.6 is not so wide. The gap is not so wide in between that percentage. So, but for group B, you will see that in the group A, that means the least satisfaction level of every individual is 2.2. That is the least, no matter the number of people there. But in group B, you will see people are with satisfaction level of 0.7, which is far less than satisfaction level of 2.2. So if you are looking at standard deviation of these two distributions, we will believe that the level of satisfaction in group A is more consistent. More people are more satisfied. The level of satisfaction of people are more. So they are not too far away from each other. But in group B, we have the minimum of 0.7 and maximum of 7.9. When we take the range in B is higher than the range in A. So the one that has smaller range shows that they are clustered together. Their ages, their differences are not too much from each other. While in the B, the differences in satisfaction level is more spread, is widely spread, is higher. So this is the kind of volatility we measure when you use standard deviation. Because standard deviation is not just for standard deviation calculated. It has meaning. And this is a way of interpreting the meaning of standard deviation. So, any question?
Doctor,
Yes.
we understand the concept. Just we wondering how it will be tested. Will the question ask to draw this bell curve or what?
Okay, how will the question be asked? If you want to ask question here. Is that what you're asking?
Yes. So for this interpreting standard deviation, so or in another words, why we need to learn this? So how do we use this to answer the question?
Okay. When do you need to learn it? You learn it so that even if you are, for example, we are in real estate, and if you are to analyze, if you have a data point, for example, you have return over the years, maybe average return year in, year out for about 20 years. You know, you can use that to predict what will be the average return in the coming year by looking at the average, right? Or you can use that to decide the expected return next year. So what do? You use the record of past years to find their average. So let's assume average is 4%. Fine. If average is 4%, what you are saying is that next year you are expecting an average of 4%. But by the time you look at the risk, which is now the standard deviation, the standard deviation will give you the spread. So if it gives you the spread, you will know whether it is more realistic, whether it is consistent or not. If it is not consistent, just like group B here, then you begin to doubt whether you have 4% or you have less. What this one shows you is that next year, the return may be 0.7, as low as 0.7, or as high as 7.9, because that is the scatter. But for group A, the return can be as low as 2.2, as high as 5.8. Excuse me. This is what the standard deviation is showing. It's showing the risk of ascertaining what your mean estimate is showing to you. Is there the chance of wavering? How high? How is the wavering? How volatile? How spread? Volatile means how the risk of achieving that? How am I going to achieve that? Is there any chance? Is the chance high or the chance is low? Does it answer your question?
Yes, yes.
Okay. So that is the kind of what standard deviation sees. And that is why we use standard deviation. If you remember in BIA 2002, when we are doing Sharpe ratio, when we are doing risk adjusted return, it was the standard deviation we used to divide. So that we'll be able to say that taking care of the standard deviation as an element of risk, this is what is expected to be a risk-free return. So that is the concept within which the standard deviation is being used to stand in for error, both in statistics or in econometrics analysis. Any other question? Excuse me. Any other question on this?
So far, no, Doctor.
Okay. I hope everyone is okay with this so that please ask question and let's attend to it. If there's any other question, if there's any question, please ask. So this is why the concept of standard deviation is important. So it tells us the spread of the mean and the scores. So if we want to find average, if we have an average, what is the spread of those scores? So from even if I don't have the data set, if I have the standard deviation and the mean, I can estimate what is the minimum value and what is likely to be the maximum value in the observation. So, and that will give me how widespread they are, how clustered are they around the standard, around the mean. If the standard deviation is small, then the data are concentrated around the mean. If the standard deviation is bigger, then that means this data is spread outside the mean, so that we will know whether the differences between the data, each data point, is big or small. And for example, let me look at it this way again. Let's say we are measuring we are taking the age of students in this class, and we are saying somebody is 21, 22, 23, 24, 21, 22, 23, 24. You know, these ages are closer than you have 21, 25, 27, 18, 19. So this is the spread we are talking about. How close is the data to each other, and how wide are they to each other? The bigger the standard deviation, the wider the differences between the data points. But the closer or the smaller the standard deviation, the closer the differences between each data point, the value of each data point. So if that is okay, because I know the calculation of standard deviation is no problem. We have been doing statistics in high school. But the interpretation now, how do we interpret it in the real estate world? So whenever we are using mean and standard deviation to assess anything, this is where we are heading to know the spread, to know how risky it is to achieve whatever estimate we have made. Okay, so now in the measure of dispersion, another concept is the measure of position. So position in the sense that where exactly what exactly will be the value at a particular location or at a particular position. This is stemmed from median. Remember, median is looking for middle value. So median is checking the value that is at the middle of a data set. So that's a position, the middle position of a data set, of the observation in the data set. So we look at other points. If we are looking at the middle point, which one will be at the first point, which one will be at the last point, which one will be next to the first and next to the last. So this is what brought about the concept of position. And location is still placed on the median, the formula to find the median. So it's an extension of the median value. So instead of the value in the middle, what about the fifth value? What about the 78th value? So the position of these data sets. So in a data set that is arranged in mostly in ascending order, we will know which data is expected to be at this position at any point, at any position that is given. So to measure position, we use quartile, decile, and percentile. Quartile means divide the whole data set into 4. At each quarter, what are the values that will be there? Decile, divide the value into 10. So at each 10 points, at each 10th point, what is the value that is located here? So then the percentile divide the entire data set into 100%. So at 20%, which data set is located at 20%? Which data set is located at 42% level of the data? So these are just the measure of position. So we are looking at the data set that is a particular point that is given. Is that clear, sir? Is that clear to everyone?
Yes, very clear.
Yes. Yes.
Okay.
Sir.
If it is clear, I have using these images to explain further what I was talking about the quartile. So for the quartile, we divided into 4. For the decile, it is into 10. And for the percentile, 100%. So what I want to make clear is this, especially in 100% or in decile, the data may be 1,000 data sets. So, you know, the 1,000 data set, 100% in a data set. But if you want to look at their percentage, you know, 1% will be about 10 of those in the line. So it doesn't really mean that the data set is just 100. It may be more than the 100, but we are talking about percentage here. So what will be the, whatever percentage that is given to us, what number will it be in the data set? So for example, in a data set of 1,000, if you say 20%, that means we are looking at the 200 data set in a 1,000 row. So it is just by percentage. So now let's look at the formula one by one to measure quartile. So it's n, whatever quartile into the n plus 1 observation. What this is saying is this. For example, if we are looking at the first quartile, we divide the total number by 4 plus 1. Whatever data set that falls within that angle will be our lower quartile observation. So also for the upper quartile observation, then the middle quartile observation, if you look at this, we know that the middle quartile observation here is median rather, because it's in the middle, the 50%. So, and again, upper quartile minus lower quartile is equally giving us the value of the median. So these are just key rules to look at to find the quartile. So let's look at this figure. I will give you this slide later so that you can practice with it. Let's look at these results. And if you want to get, these are the rental estimates that has been collected. If we want to get the quartile for this data, what we do is, what is the total number? I think this is 7, 14, 24, 30, 41, okay, 50. The total number here is 50. So if we want to get the quartile, we will look at n over 4, that's 50 over 4, and 50 over 4 will give us 12.5, or what is it? 50 over 4, that's 12.5, yes. If 12.5, then the formula say n plus 1, right? 1 over 4 n plus 1. So if you get 12.5 plus 1 will give us 13. Then we look at what figure or what observation fall within the number 13 of 13.5. So when we look at this, we see the 13 will fall in within 500 range. When we have 2, 5, 7, that's 14, then 13 will fall in within the observations that are 500 because we have 7 of them. So definitely the lower quartile here will be 500 because observation 500 will be the 13th or 13.5 observation. So here, is that taken? So since we have this 150, our lower quartile, let me see if I can quickly. So lower quartile, what symbol did I use? Okay, LQ. Okay. LQ, lower quartile will be N divided by 2 plus 1. If we say N divided by 2 plus 1, and this will be, we use N divided by 2 plus 1, this will give us 50 divided by 4, rather by 4, sorry. We are looking for lower quartile. And this gives us 12.5 plus 1 which is 13.5. So what we are saying is that the value we are looking for will be on the 13th, observation. And we can get it from this table by making sure, by having a cumulative frequency. Let's convert this to cumulative frequency. And this is 2, this is 7, this is 14. So that means the observation we are looking for is before the 14th observation. And the observation that falls before the 14th is still 500. So we can say that our lower quartile, our observation at the lower quartile is 500. So the rent at 500 is observed to be at that level. Is that clear? Hello?
Yes.
Okay, this is clear enough. Now, so we can adopt the same formula to get the upper quartile and to get the interquartile range. So I will give you this slide, and I will expect you to practice it to get all other quartile so that we keep abreast with what we are doing. On Thursday, I heard Thursday is a public holiday. Is that correct?
Yes.
Okay, that means we will not be having tutorial on Thursday. So I will release this slide for every one of you to try it as tutorial for Thursday. Okay.
Doctor,
Yes.
if I'm mistaken, Thursday is a public holiday.
Thursday. Thursday is public holiday, right?
Yes.
That's why we will not be able to have tutorial, because it's a public holiday. But I will release this slide so that everybody will now can work other ones. Normally, in statistics class, when it's involving calculation like this, I always prefer to work it in class rather than working it and giving it in slide. So we work it together in class so that everybody knows the step we have been taking. So if there's any mistake, we identify. So since this is what we will have done on Thursday to work them out after these explanations. But since we are not having tutorial, because of the public holiday, I think every one of us can use it as at our lecture time to go through it so that when there's going to be any question next class next week. Because we need to work with time. So here, this is the formula for group data. You know, in group data, when it is grouped, the same thing happens. We can equally get the cumulative frequency as well, so that we get what is the total frequency. Then we look at this formula, which says lower will be the lower boundary or lower limit plus 1/4n minus cumulative frequency of the class before the lower boundary divided by the frequency of the lower boundary class multiplied by the class interval. So you can see that this formula is similar to median even for group data. It's only that it is n/2 instead of n/whatever quartile. So when in measuring quartile, it can be, when you are finding the lower quartile, it is n/4. If we are looking for the upper quartile, it is 3/4. That is just the difference between the formulas. So, and it is adapted from median. I hope we will practice it as for our tutorial day. So I will leave it open. So everybody try it, and maybe the next class we compare the results, if there is any difference in results getting by each student. Is that okay?
Okay, Doctor, can you go back to the previous slide, the ungrouped data one?
The previous, okay. This is
Just for a while.
this one. So this is an observation. So, and we are looking for the lower quartile, or what can be called Q1. It is also called Q1, but the one is a subscript. Let me make it a subscript.
Doctor, I'm confused a bit because the formula using n/4 plus 1 is different from the formula you found.
N, okay, let me see.
A bit different.
N/4, this one.
Yes, a bit different.
Oh. Normally it is 1/4n plus 1, but the bracket should be out. And you can see here, it is 1/4n. Can you see? Maybe typing error. But even if you do n plus 1, you will still fall within, for example, the one we did the other time, 50 plus 1, that will have given you 51. And if you have done 51 divided by 4, what will it be?
12.75. A bit different.
So then the 13th figure is still going to be the, so I think it's supposed to be 1/4 n plus the next observation. Okay? Okay? Do we understand that? The question, I understand your question. Do others understand the question? I want to be sure that others understand what you have asked now. Okay, then is that the only thing you want to call our attention to here? Is other thing clear to you? Hello, class. Can I move on?
Okay.
Okay. So I leave this for tutorial. Either we do it at home or we come back to it in class. Then the same thing for decile. So we look at the percentage, then n plus 1. Okay, this same thing. Okay, this 25th, let's rewrite this because this one has been typed for a long time. Now, instead of using quarter, when it comes to decile, we use either decile or percent. When it comes to decile, we use 10. Instead of dividing by 4, we use 10 because 10 means decile. In 10th places, when you share data into 10 places, what data will be at the first 10, what data will be at the second 10, what data will be at the third 10th. So that's why they arrange it from D1, D2, D3, D4 until D10. So in the same equation, the same formula, instead of 4, you substitute for 10. And the same thing is in the percentile, 4 or 10, it is 100. So let's see if we can use this same data to do at least either decile 2 or decile 3, at least to try decile 2. And if we want to do that, I just want to copy this. So let's try and change this to the D1. Decile 1, or whatever we want to, or whatever there's figure, maybe we can use 3 or 4 instead of 1. 1 is too close. Decile 4, let's try 4. D4. So that means n will be divided by 10. N will be divided by 10. And this will now be divided by 10. Am I? Yes. 10. So if we divide this by 10, this gives 5 plus 1. 5 plus 1. That means the sixth observation will be one value. So, and when we look at the sixth observation, then the sixth observation fall within 350 rental class, and that will give us 350. So this is as simple as it could be. So now we have at the sixth observation is going to be our D4. And if we have sixth observation as our D4, then the sixth observation is 300, fall within the 350 RM renter. And similarly, if we want to do percentile, maybe we are talking about 65th percentile or 70 or 80, 65th percentile, and then 56th percentile number will be, we divide by 100, n by 100. And if we divide n by 100, we have 50 by 100. By 100. 65th position. What is 50 by 100? And this is 1/2, I think. No, something is wrong here. 60. Oh, 60. No, by 65, I mean. Something is wrong here. No, let me check the formula again. 65th. 65th over 100, okay. Multiply by n. Sorry. Here. Something is, oh. This will be 4/10. Sorry, something is wrong here too. This should be 4/10. 4/10 into n plus 1. Oh. The attention you are calling me to here. So it's 1/4 into n plus 1, truly. This is 1/2. This is 3/4. Sorry, I cannot, now I understand your point. Please correct. So this one will be 4/10 multiplied by this, n minus 1. Oh, n plus 1. And let me correct it, please. This is 1/4. Oh, into n minus 1. I just n plus 1. So, and this is okay. This is stay correct because it's 1/4. This is 51 divided by 4. This go to 0.75, meaning that the 13th, since it's above 12, the 13th figure will be, which is still 13th observation. Okay, so this one is 4/10 into n plus 1. This is 4/10. And 4/10 is 0.4. Oh. This is 0.4 into 51. And this is, what will be this? Somebody have calculator, please help me out. 0.4 multiplied by 41.
Doctor should be 51, right?
51, right?
Yeah, here's
Multiply by 51.
20.4.
20. 20.4 observation, right? 20.4 observation. So the 20.4 observation, we now look at the 20. Which one fall with? Okay, this is 24. So the 20.4 observation will fall, that is after 28th observation, the next observation. That would be fall within 700. So I think that is corrected now. Then if we're looking for percentile, the 65th percentile will be 65 over 100 over 100 into n plus 1. And that will be 0.65 multiplied by 51. 0.65 multiplied by 51, please. That will be 30 something.
30.
Observation.
15.
0.65 multiplied by 51. 33.15. That will give us 33.15 observation. So 33.15 observation will be what is our 23.15 observation? Let's look at which one will fall within 33. This is 24 plus 6, we get 30 plus 11, 44. That means our 33 observation
41.
will fall within this 41. Oh, thank you. 41. That means our 33 plus 1 observation, because this is more than 33. After 33 observation, the next observation is in 34, and they both fall within this range of 1000 RM. So the observation, the 65th observation in this data will be 1000. So, yeah, this is the proper way of transferring this the expression here. Thank you. And this is how we put in the formula for every observation we are looking for. If it is decile 5 or 7, we put 7 over 10 and it goes. And we look at the data that fall within whatever number of observation we are looking for. So that is why cumulative frequency is still important. So for group data, we do cumulative frequency, no doubt. So that because the cumulative frequency before the class is going to be used when we are doing our calculation. Is that clear now, class?
Doctor, we are clear now. Can
Okay,
doctor do one more for the interquartile range?
Interquartile range. So interquartile range is just we will do upper quarter so that we will do interquartile range. Okay. So we still have some minutes. We can do that. So want to do upper quarter. This is Q3. Upper quarter is normally some people refer to upper quarter or Q3. Now this will be 3/4 into n plus 1. So this will now be the 3/4. That will be 12.75 multiplied by 3. And this is 3/4 is 0. What? 0, okay, 3 times 51. That's 153/4. 153 divided by 4. So somebody about
38.25.
153 38.25.
0.25.
Okay. And this is 38.25. 38.25. So that means the observation after the 38 observation will give us the upper quarter. So good, we have 41 already here. So the next one after 38 will have been 40. That means still 1,000, right? So this is because we have 11. This is 38 plus 1 observation. So after the 38 observation, we still have 1,000. Good. So this is 1,000 for this. So interquartile range will be interquartile range is the difference between upper quarter and the lower quarter. Interquartile range equals upper quarter minus lower quarter. This is 1,000 minus minus 500, which is 500. This the 13th observation is 500. Yes, 500. Look at it. Upper quarter minus lower quarter, interquartile range is 500. So let's look at this is 25. No. This is strong. 40, 24, 41. Okay. Let's look to 2 times 50, 100, that's 35. No. Q3 minus Q1. Q3 is 1,000, Q1 is this. Let's I'm looking at this. Q4 38, 39. Okay, 3/4. Yes, n minus 1, 51 times 3, 153/4, 30.5. That's it observation. So the 30th observation is this. What is the Q3? No, this is 38 minus 13. The Q3, sorry, the Q3 observation is 38.5 observation, right? 38.25 minus 12.75. So, and this will be
25.5.
25.5. So the observation at 25.5 observation, 25.5 observation.
800.
So 25.5 observation is 25.5 observation is 800. 25.5. Okay, this is 24, this is 25. 25.5 observation, 800. Okay. So the observation at upper quarter minus lower quarter is 25.5. So the observations value at 25.5 is 800. And look at, yes, 800. Now, let's look at the spread. That means it is the half 25.5, you know, half, because the total number is 50. It is half, the 50, the 25th and 20. If it is 25, you know, 25th and 26th will be added together and find the average. So this is correct. Now this is 800, and this is actually the middle value and actually the median. So at least looking at this, we can say that the upper quarter and the lower quarter minus lower quarter is equal to the median. Is that all right now? Hello?
Yes, Doctor.
So I will leave this like this and put it in the slide I will upload, so that we can use it to do a little bit tutorial about other data set I put in here. Any other question? We are almost at the time.
Doctor, how
Yeah.
about for the interquartile range, I use the result of the Q1 and Q3. So is it like just now what you did just now for the first time, for the first try for the interquartile range?
You know,
Is that wrong?
we are looking at the position. Remember, we are looking at the position. Then when we find the position, we now look at observations that fall within that position. Is it right? Do you understand what I said? You know, the first thing is we are looking at our lower quarter is 12.75. That means the 12.75 is the lower boundary. So when you are looking at the range quartile, these are the figures we are looking at: 12.75, 38.75, 25.5. So the observation that fall within that position is what we are interested in. what observation is in that position. At the position 12.75 for Q1, the observation that fall within it is 500. That means observation 500 position, or that's, we are looking at what observation fall at the 12.75. So if you do the same thing, you take the upper quartile away from the lower quartile, then you look at the observation there. The observation is what we are really interested in, because we are looking at the position. The position is position 25.5 for the interquartile range. That's the median position. So when we get to median position, what observation is there? That's why we try to look through the cumulative frequency to identify the exact value of the observation that we have at that position. Yes? Does it make clear? Hello? Is it clear now? Because if you look at the observations, then you now look at the what is the observation, the position, what is the observation, what is the data that is at that position. Hello, does it make it clearer? I can hear your response. So, or maybe I didn't get your question right. What was the question here?
Doctor, or can you double check? Because what we learned during secondary school, we directly use the answer for Q3 and Q1.
Which is what? Which one? 12.75 or 500? I want to make it clear, and I want to get you clearer. You know, when you get lower quartile, you get 12.75. That is the quartile, right?
Okay.
That is the quartile. You know, it's like you divide 50 into 4 places. You know, you get 12.75, you get another figure, you get another figure. Are you right? Especially in this scale. I'm looking at the scale I used to explain it so that we place it on the scale. For example, we say Q1 is 12.75, right? Then Q2 will be this, Q3 will be this. But now, remember on this line, a lot of observations are there. We have one observation here before we get to 12.7. So this is the position, the Q1 is the position. But the observation that is at the position is what we are finding. Okay? So what figure, what is the data set here? Okay, let me explain it by like this. Let's assume that everybody in this class line up and we are about 50. So we are looking for Q1. Q1 will give us from number 1 to number 12.75. So that's Q1. My interest is who is that place? Who is lining up in that place when I begin to identify people? Who is that person at the point 12.75? Do you understand now? Hello?
Doctor, I think, we understand Q1 and Q3. It's just that the range usually is like the difference between the two. Like what's in between?
Yes, the range is between the two. Okay, for example, if you have Q1, Q3, the range between these two is your Q2. But here, what I'm saying is that Q2 is giving you the position. All Q1, Q2, Q3 is giving you the position. But the observation that is at least on that spot is what we are interested. That's why I'm trying to look at. Let's say in your class, everybody is lining up. And we have found Q1 to be 12.75. You know that figure 12.75 is telling us the position.
Doctor, know what's wrong? It's a group data. So we need to use the formula for the interquartile range. We need to use for the group data. We cannot use the Q3 minus Q1. We need to use the interquartile range formula for the group data, or just now, the question just now.
No, okay. But look, the question is, I want to put across is, my interest is the observation at that point. So we spread, we can rewrite the information on this table here. Let's say we are writing it. I just want to demonstrate. We are out of time already. So let's say we are lining it up. See, okay. Do I have space here? Is it clumsy now? So that I'll move to, okay. Okay, I want to, okay, Control X. Let me insert another new slide, okay? So let me just say Control V. Now, instead of writing this, so can you be giving me the figure? We have 350, another 350. Sorry, you cannot give me the figure. Let me see this one again. Oh, 250, 250 two times before 350. So let's say 250, 250, 355 times. 350, 350, 350, 1, 2, 3, 4, 5. Then we have 500. Blah, 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 blah. Let's like this. So let's assume, okay, let me move this 500 to be more so that I will be able to explain what I'm trying to do. Okay, let's look at this. Now our lower quartile is 12.75. We approximate at 13. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, the next one is 13. So this is the position of lower quartile. This is the position of lower quartile. Okay. Is this chart trying to say something? So because of the total observation, you have gotten your lower quartile to be here. So my interest is this. What is the renter here? We serve as my lower quartile value and lower quartile observation because I'm looking for the observation. So if we look, okay, 1, 2, 3, 4, 5. If we look at our data, what data is there? 1, 2, okay, this is 7 times. So we still have, that means here is another 500 again. So the 13 data is another 500. So what I'm saying is that I know this is 12.75. I am interested in the data here. What observation is there? And the observation gives me 500. Is that okay?
Yes.
Now, if we go on like that, we will see the 25th observation, then we will see the Q3 observation. So if you see the Q3 observation, what observation was at the Q3? That's 1,000. Can I type everything? It's too long. Okay, 500, 500, 700, 700, 700. Okay. Let's see if I can type everything so that we illustrate what position we are. So I will be seeing it and copy from here. So the next one is, okay, 1, 2, 3, 4, 5, 6, another 500. How many 700? 10 times. Okay. $700. 1, 2, 3, 4, 5, 6, 7. Okay. So I have 800. 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 1, 2, 3, 4, 5. 8. I have 1,011 times. Leave class. Please mark your attendance in Spectrum. I think you have done that. One, two, three, four, five, 6, 7, 8. And then I have 1, 2. One, two, three. Okay. Okay. Then we have 155 times 1,500. 1,500. 1,500. 1,500. 1, 2, 3, 4, 5. And 2001. I think the data set is complete now. Okay. So this one can go. Now, we have gotten our lower quartile to be 13th, let's say 13th observation. So, and the 13th observation here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Let me see what I can do. So, let's just mark it with this. This is the 13th observation, right? The next observation is the upper quartile is 38, maybe 39th observation, because after 38. So 39, let's say that would be minus 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. This is likely to be the, and I do this again. Okay. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, it's this one. So my own explanation is this. This is the lower quarter observation. This is the 13th observation, right? And this is the upper quarter observation. Is that clear?
Yeah.
Okay. Now, let me now get you correctly now your question before I do the interquartile range. Because I want to get the point of agreement where we are. Are we looking for the interquartile range? Of the observation? I want to get it clear so that we are both clear of what we are saying. It's like I'm not understanding what you are asking.
Doctor, our concern is that we always use the upper quarter, meaning that 1,000 straight away minus 500, not use the observation.
Okay, that's okay. You are asking about interquartile range of observation. Is that your question?
For the interquartile range, we use 1,000 to minus 500.
And what I'm saying now is this. The interquartile range for 1,000 minus 100 is about the interquartile range of the observations, not the position, right?
Yeah.
Do you get that?
So if there's a question, do they specify that the interquartile range is for the observation or the?
Yes, if this interquartile range of the observation, 1,000 minus 500 give you the interquartile range of the observation, just like range of all observation. If you are looking at range of all observation here, you know, the minimum, if we are looking at all, the minimum is 250, the maximum is 2,000. So the interquartile range or the range of the observation is 2,000 minus 250, agreed. So if you are looking at the interquartile range of the observations, that means you are looking at the range between the observation at the lower quarter and the observation at the upper quarter. If that is what you are saying, then it is 1,000 minus 500. Okay? But if you want to use the upper quarter position and lower quarter position to get the median, so then we take the value of the upper quarter minus the value of the lower quarter, then we look for the data that fall into that difference to get the median. So is my position now clear?
Yes.
I think we were talking of different things before. You are talking about range between observations, which is one, to know just the range, which one is the smaller, which one is the bigger. Just as range in statistics in the observation. But I'm talking about using the interquartile range, which is the formula for the range for the lower quarter and that of the upper quarter to find the median observation. That was what I was explaining. So that we'll be able to find the median observation to be sure that the value between we can use the difference between the quartile, the lower quartile and upper quartile to find the median observation. That was what I'm trying to explain. Is it clearer now?
Yeah, doctor. So if in the test or exam, when the question asks about the interquartile range, which one should we apply?
So when we ask for interquartile range, if you want you to learn that it will clearly specified. We will only lose interquartile range differences to locate the median. You understand? You know you are locating the median. Do you understand me? It will not be clumsy for you to do because I'm just trying to prove that the difference in the quartile range, can locate the median value so that they can ask you to use that to find your median instead of calculating median again, especially when you have group data. Okay?
Okay, understood, doctor. Thank you.
Okay, thank you for this clarification. So do I leave this in the slide when I'm sending it? Or is it not necessary again? Because I just use it to illustrate the position the two of us are so that we get it clear. And I think it's clear now. So maybe I will add something to it. Yeah. An expression to it to make it clearer. So I will leave it there.
Doctor, is that it?
Yes?
Is that all for class today?
Yes, yes, since we have, it's only this what we want to get clarification of that take us this long. I think if you have done your attendance, the class you can exit the class. Okay?
Thank you, doctor.
Yeah, so I will upload the slides now so that you can use it to do your practice.
All right, thank you.
Yeah.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Thank you, doctor.
Thank you, Doctor.
Thank you.